So we are going to see the analysis of deformation. It's structural geology. So strain associated with homogeneous deformation. So homogeneous deformation is the deformation where the squares, if a square is deformed, then it will remain square. Yes, its area may increase, but it will remain square. It will not get distorted. So homogeneous deformation at constant volume may involve because of the number of strains. Okay, so first one is axially symmetrical extension. It involves extension in one principal direction. So here lambda 1 is extended, and constriction in other two direction. So it's the formula: lambda 1 is greater than lambda 2, and the lambda 2 and lambda 3 is equal. Okay. And such strain is known as strain ellipsoid or prolapse or constrictional. So it's constrictional because the most number of axes are constricted. It is known as cigar shaped deformation. Okay. Cigar. Next one is axially symmetrical shortening. So it's written shortening. Okay, it involves shortening in one principal axis. There the lambda 3 is shortened, lambda 2 and lambda 1 extended. Okay. Lambda is shortened. First, lambda 2 and lambda 2 remains equal and extended. Okay, and the strain ellipsoid is an oblate spheroid flattening is known as pen. Number 3 is plane strain. So what about plane strain? Here the intermediate is taken as constant, and the lambda 3 is shortened, and lambda 1 is extended. Okay, lambda 2 is constant. So lambda 1 is greater than lambda 2 greater 1, then lambda 3. Okay. Triaxial ellipsoid or plane strain ellipsoid. Next will be general strain. General, here all extended. See. Lambda 2 is shortened, lambda 2 is extended, but lambda 1 is most extended is lambda 1. This is shortened. See, lambda 1 is extended, lambda 2 less than lambda 2 and less than triaxial ellipsoid also. Number 4 is pure shear. So it's a bit confusing, not you need to concentrate more. So it's an So it pure shear, it is an irrotational strain. See, irrotational means there is no rotation, only extension. Only extension is there, no rotation is involved here. No rotation. Then they can overlap each other. They can overlap each other. Now, where the lines of particles parallel, so there is no rotation along the principal direction. Hence, they are irrotational. Since there is no rotation, so they are termed as irrotational deformation. Next will be the simple shear. This is a rotational, right? This is a rotational strain. Here xy deformation direction do not coincide. See, this is the x with this is the x, this is the x, and this is the z. They do not coincide. See, this x goes here, they do not coincide, they do not often overlap. So there the rotation is there in this particular particle, a rotation is there. Okay, a rotation is involved. Now simple shear is a constant volume homogeneous deformation involving plane strain in which single family of parallel is undistorted and deformed state, xy planar and parallel to the same family of planes in the undeformed state. So it's nothing. Going to the next, it's just simple shear. It's simple shear. Simple shear involves rotation of material, so it's a bit more about the previous one. It's get rotated. Okay, it's get rotated. It's getting rotated. Such a known as simple shear is, and see, the pure and simple shear are very common, but the combination they do not occur individually. Okay. Next we have the finite strain. The finite strain is difference between the final and original strain. This is the original strain, undeformed one. Wait, this is the original undeformed, and this is the final. So F minus U equal to finite. Okay, finite, and it depends upon the strain commences and when it stops. In other words, finite strain is the total strain in each rock at a given locality. So what? Finite strain is the total strain in a given locality. It varies in orogenic belt. Plus 2 plus. Next we have the incremental. Increment. This is increment. It's just a small amount. It's just a small amount. Okay. So incremental strain is a very small amount of strain required to bring the already deformed body to a more deformed state. So it's a, we take it's a deformed body. Okay, plus increment, I is the increment, level it will get more deformed. Okay, this is increment strain. Therefore, a large number of incremental strain. So if we go on carrying so I to the power n, this is the n, and increment, then we will get the finite. Okay. 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 So this was all about the structural geology, which is structural geology based on the analysis of deformation. On the next video we will go with some other topics also. So up to then, thank you.